Earth has not always been peaceful. For hundreds of millions of years, life has stood on the brink of annihilation many times. Oceans drained away, giant volcanoes swallowed the skies, or asteroids struck like a death sentence. Each time, more than 70% of species vanished in the blink of a geological eye. Yet after each catastrophe, life on this planet regenerated and reached new heights. There is no guarantee that such a doomsday will not happen to us. To understand the disasters that once wiped out life, we first need to know the concept of mass extinction. These are events when the majority of organisms on Earth, from the deep sea to the land, disappeared within a very short time on the geological scale. Scientists usually define it as about 75% of species vanishing in less than a few million years. It may sound long, but on Earth's 4.5 billion year timeline, it is only a blink. To put it in perspective, if Earth's history were compressed into 24 hours, life would appear around 5 o'clock in the morning. Dinosaurs would only step onto the stage around 11 o'clock at night, and modern humans would show up in the very last few seconds. In that brief moment, life has been erased almost completely many times. These resets were not only destructive, but also opened opportunities for new groups of organisms to rise, paving the way for entirely different eras. Now that we understand what a mass extinction is, let's rewind time to 444 million years ago, when life still lived mostly in the oceans. This was the very first recorded mass extinction in Earth's history, and it was so brutal that an estimated 85% of marine species vanished. The Ordovician was a time when the seas teemed with life. Ancient coral reefs flourished, invertebrates like brachiopods, two-shelled creatures that looked like clams but were different, trilobites, and countless plankton species dominated the oceans. On land, life was still sparse. Only a few mosses and lichens clung to rocks. No forests, no land animals yet. In other words, from afar, Earth at this time was still very much a planet of oceans. Geological evidence shows that the main cause of this catastrophe was a global ice age. As the ancient continents shifted, they clustered near the southern pole, fueling massive ice formation. Huge glaciers began to build up on the supercontinent Gondwana. The result was a sudden drop in global sea level, a fatal shock for marine organisms that depended on shallow coastal waters, where sunlight could reach and food was abundant. As the seas receded, countless habitats disappeared, like pulling the plug from a giant aquarium. Moreover, temperature shifts disrupted the ocean's chemical cycles. Oxygen levels in the water plummeted, creating dead zones where hardly any life could survive. This was a double storm. Creatures lost their homes and suffocated in their own oceans. The outcome was the disappearance of 85% of marine species, including many once prosperous groups. Creatures that had dominated the seafloor suddenly remained only as traces in fossils. Coral reefs, the symbol of abundance, were almost completely destroyed and took more than 100 million years to recover. Trilobites, once widespread across all oceans, lost much of their diversity. Though they survived this disaster, they never regained their former glory. In a sense, the Ordovician extinction was evolution's first great filter, eliminating much of the planet's young life. Yet despite its brutality, the Ordovician catastrophe opened the way for new groups of organisms to rise. With much of the environment left empty, the lucky survivors had the chance to diversify further. From here, in the following Silurian period, life began to build more complex ecosystems, laying the foundation for the biological explosion to come. After the Ordovician catastrophe, life slowly recovered. The oceans once again became a paradise for countless creatures, and on land, plants began to take root and rise. But then, around 375 million years ago, a new crisis quietly unfolded, this time not as a sudden shock, but as a slow death that lasted millions of years. This was the late Devonian extinction, when about 75% of species vanished from the planet. The Devonian is often called the Age of Fishes. The seas at this time were the stage for giant creatures. Placoderms, armored fish reaching several feet long with jaws like crushers, roamed the waters. Early sharks appeared, and corals along with mollusks thrived spectacularly. On land, plants had exploded in diversity. The first vascular trees grew into forests, transforming the entire atmosphere by absorbing carbon dioxide and releasing oxygen. This was a turning point. Earth began to have green forests, and insects and amphibians were taking their first steps onto land. Unlike the Ordovician, the Devonian extinction did not come from a single cause, but from a combination of many factors. First was the oxygen crisis. As forests spread, organic matter fell into rivers and streams, flowing into the sea. Its decomposition drained oxygen from the oceans, creating vast dead zones. For the first time, green plants, symbols of life, unintentionally became the culprits that drove many marine creatures to a dead end. Next was volcanic activity. Evidence shows massive lava eruptions that released carbon dioxide and heavy metals into the environment. Climate swings between hot and cold, along with ocean acidification, made survival even harder for organisms. Finally, asteroids and climate upheavals. Some hypotheses suggest asteroid impacts also played a role, though likely less significant than the oxygen-depleted oceans. The Devonian extinction unfolded in multiple waves, lasting about 20 million years. Coral reefs, which had flourished for hundreds of millions of years, collapsed completely and did not recover until 100 million years later, when new types of corals emerged. The giant placoderms, rulers of the seas, disappeared. Many primitive fishes, mollusks, and plankton species were wiped out. This was not just a loss in numbers of species, but the collapse of pillars that upheld marine ecosystems. On land, plants and animals largely endured, though climate fluctuations made life difficult for many young amphibian species. This pushed evolution strongly toward animals capable of living fully on land. If the Ordovician was a cold shock that left the oceans suffocated, the Devonian was more like a lingering illness, slowly draining life from the seas. And this was only the warm-up. For soon, Earth would face the most devastating extinction in history, the time when the planet nearly became a completely dead world, the Great Dying at the end of the Permian. If the previous extinctions were like sudden shocks or long illnesses, the end Permian event was the true death blow. It is considered the most terrifying extinction our planet has ever endured, so extreme that scientists call it the Great Dying. In this event, 96% of marine species and 70% of land animals disappeared, nearly erasing life itself. The Permian period was a time of great transition. All the continents had merged into one giant supercontinent called Pangaea, surrounded by the vast Panthalassa Ocean. Life was extremely diverse in this era. On land, primitive reptiles and therapsids appeared, some of which were distant ancestors of mammals. In the seas, corals, mollusks, insects, and fishes flourished. Trilobites, icons from ancient times, still existed, though they were already in decline. In short, it was a vibrant, lively planet. But in a short span on the geological timescale, nearly all of it vanished. Scientists have uncovered many clues, and most agree that massive volcanic eruptions in Siberia were the main culprit. About 2 million square kilometers of land were buried under lava, forming basalt layers that still exist today. The consequences of this volcanic activity were catastrophic. Trillions of tons of carbon dioxide and methane were released, driving global temperatures sky high. Carbon dioxide dissolved into seawater, killing calcium-shelled organisms like corals and mollusks. As the climate heated, ocean circulation shifted, creating enormous dead zones where oxygen dropped to nearly zero. Some studies suggest sulfur from the lava and leaking methane filled the atmosphere with toxic compounds, weakening the ozone layer. In other words, Earth became like a giant pressure cooker, extreme climate swings, suffocating air, and oceans poisoning their own life. The result was mass annihilation. In the seas, 96% of species vanished, including the trilobites, which had survived multiple past extinctions but were now gone forever. Coral reefs disappeared completely. On land, 70% of animals perished, including most dominant therapsid species. Insects also lost many important lineages. Ecosystems collapsed so badly that Earth was nearly transformed into a barren planet, a dry and suffocating wasteland. For millions of years after this event, Earth was almost devoid of biodiversity. Fossils from immediately after the Permian show recovery was painfully slow, with ecosystems monotonous and impoverished. If the Ordovician was a warning bell and the Devonian a slow death, then the Permian was the fatal strike, nearly ending all life. And that was only the middle chapter. For after life recovered, this planet would once again face further waves of annihilation, including one that cleared the path for the rise of the dinosaurs, the end Triassic extinction. After the Great Dying at the end of the Permian, Earth needed millions of years to recover. Ecosystems were simple and impoverished, but gradually life revived and became diverse again. By the Triassic period, the planet was once more filled with new species, lush plants, abundant insects, giant reptiles, and enormous amphibians ruling the swamps. But then, about 201 million years ago, another extinction struck. Not as catastrophic as the Permian, but powerful enough to wipe out many species and open the golden age of the dinosaurs. The Triassic was a unique era. Everything was still united in the supercontinent Pangaea, surrounded by a vast ocean. The climate was harsh. Summers were extremely hot, winters extremely cold, and deserts stretched across much of the land. Giant reptiles were diverse, from archosaurs, the ancestors of dinosaurs, crocodiles and birds, to therapsids, the distant ancestors of mammals. There were also many massive amphibians, some stretching several yards long, dominating the swamps. Dinosaurs at this point were only a small group, far from dominant. They lived alongside many formidable rivals and had not yet taken control of the planet. Geological studies show that the end Triassic catastrophe was closely tied to the rifting of the supercontinent Pangaea. As the giant landmass began to split, the Central Atlantic magmatic province, camp eruptions occurred, unleashing enormous volcanic activity. The result was a surge in greenhouse gases. Carbon dioxide from the lava caused global temperatures to swing violently. Much like the Permian, seawater became poisoned, and many marine organisms could not survive. Some studies suggest that sudden climate fluctuations caused already fragile ecosystems to collapse rapidly. The result was the extinction of about 70 to 75% of species. The giant amphibians disappeared almost entirely, ending their reign over the swamps. Many reptiles that competed with dinosaurs, such as phytosaurs, crocodile-like giants, and etosaurs, armored reptiles, went extinct. Marine life also suffered heavily, with many mollusks, corals, and primitive fishes vanishing. This disaster created an enormous ecological vacuum. And it was within this vacuum that dinosaurs rose powerfully, becoming the dominant land creatures for the next 150 million years. After surviving the earlier extinctions, dinosaurs enjoyed more than 150 million years of absolute dominance. They became the ultimate symbol of strength and diversity. From giant predators like Tyrannosaurus rex to long-necked giants like Brachiosaurus to flying pterosaurs and armored dinosaurs. Alongside them were countless other creatures, massive marine reptiles like Mosasaurus, primitive birds, and flowering plants blooming across the planet. But then, about 66 million years ago, a fateful day struck, a catastrophe that remains the most shocking story in Earth's history, the Chicxulub asteroid. Before that, during the Cretaceous period, the planet was a warm world, with high sea levels, forests, and grasslands stretching wide. Dinosaurs were everywhere, from the tropics to the polar regions. It was a golden age, a mighty empire that seemed impossible to fall. Yet beneath this calm surface, the sky was preparing to receive an uninvited guest, a giant celestial body about 6 miles in diameter, hurtling in from space. Around 66 million years ago, this asteroid struck the region that is now the Yucatan Peninsula in Mexico. The impact released energy equivalent to billions of nuclear bombs. In an instant, a crater more than 93 miles wide formed, today known as the Chicxulub crater. The temperature at the impact site was high enough to vaporize rock and metal. Shockwaves spread across the planet, triggering earthquakes, volcanic eruptions, and massive tsunamis. Imagine an ordinary morning for the dinosaurs, the sun rising, the jungle rustling, and suddenly the sky flashes and everything is consumed in a fiery hell. This disaster was not just an instant explosion, but a chain reaction. Material blasted from the impact shot into the atmosphere, forming a dense dust layer that covered the sky for months, even years. Sunlight was blocked, plants died en masse, and the food chain collapsed. Global temperatures plummeted and the climate shifted abruptly. Cold-blooded animals and large plants struggled to adapt. Sulfur and carbon dioxide from the impact mixed into the oceans, turning the water toxic and wiping out many marine species. The result was the extinction of 75% of all species on Earth, including almost all non-avian dinosaurs. Giant marine reptiles, pterosaurs, corals, and countless others also vanished. Forests, once shaded by massive dinosaurs, were reduced to carcasses. A mighty empire that had lasted hundreds of millions of years ended in an extremely short span, almost overnight on the geological timescale. But not all life disappeared. A few small groups survived, thanks to special traits. Tiny mammals, living in burrows, active at night and less dependent on large plants. Some primitive birds, descendants of feathered dinosaurs, small enough to adapt. Small reptiles, fish and insects, species able to withstand harsh conditions. From this group of mammals, tens of millions of years later, humans finally appeared. Looking back across hundreds of millions of years, Earth resembles a giant stage. Many times the play of life seemed to end forever. The Ordovician, when ice consumed the seas. The Devonian, when the oceans were strangled by lack of oxygen. The Permian, when the planet became a deadly inferno. The Triassic, when volcanoes and toxic gases cleared the way for dinosaurs. The Cretaceous, when an asteroid ended their empire in a flash. Each time, life suffered immense losses, from 70% to nearly 96% of species gone. Yet miraculously, from the shadows of extinction, life rose again. The smallest, weakest creatures often became the survivors, opening new eras. And that is why today we humans are here to tell the story. What's worrying is that many scientists believe Earth is now entering a new mass extinction, and this time the cause is not an asteroid or volcano, but humanity. This is not without evidence. Global temperatures are rising faster than ever in recent geological history, causing ice melt, sea level rise, and extreme weather. Rainforests, coral reefs, grasslands, the richest ecosystems, are vanishing at a frightening pace. From elephants and rhinos to sharks and whales, many species are declining because of human demand. Plastic waste, chemicals, and oil spills are poisoning the marine food chain. Estimates suggest that species today are disappearing 100 to 1,000 times faster than the natural extinction rate. If this trend continues, the 21st century could mark the beginning of the sixth extinction. And the greatest difference is that this time it won't take millions of years, but only a few centuries or even a few decades. Yet unlike dinosaurs or trilobites, we have awareness and the ability to choose. We know the causes, foresee the consequences, and have the technology to change course. The question is no longer, will extinction come? But do we dare to change to stop it? Earth has existed for more than 4.5 billion years and will continue long after humans are gone. But our own future depends on how we act today. If not, we will only become another sad chapter in this planet's chronicle of extinctions. If you find this subject thought-provoking, please share the video so more people can know about it. And don't forget to subscribe to follow more fascinating videos.